For part one of this lecture, we're going to look at scatterplots. Scatterplots are very useful when you have two numerical variables, and then we're going to relate that to this concept of covariance in just a bit. So when we visualize numerical data, so far we've looked at really just a single numerical variable. We have dot plots, histograms, box plots, also known as box and whisker plots, but the point is there are lots of different tools we have for visualizing a single numerical variable. But how about two numerical variables together? How can we visualize those? With two categorical variables, we've talked about mosaic plots as a way of visualizing two categorical variables. But for two numerical variables, we can use something called a scatterplot. So let's look at obesity in the United States. Suppose you're an epidemiologist who is interested in nutrition, and you want to examine the obesity epidemic in the United States. In particular, you want to know what state-level characteristics are related to the percent of people who are obese. And so in the United States, we have 50 states, and you collect a data set of 50 US states, and what you do is you start creating scatter plots just to kind of examine what relationships there might be between various numerical variables and the percent obese in different states. So here's our data set on obesity in the United States. You can see that we have 50 rows because there are 50 US states, so each row is a different state. And we have several variables. First of all, we have a variable called state for the name of the US state, Alabama, Wyoming, Wisconsin. Then we have this variable for obese. This is the percent of people in each state who are classified as obese, which is severely overweight. And then we have a variable for non-white. This is a variable giving the percent of people who do not identify as white based on survey data. And then we also have a few other variables. We have a variable for the percent of people who report eating at least 5 servings of fruits and vegetables each day. And then we also have a variable for smokers, the percent who smoke cigarettes regularly. All of these are numerical variables, with the exception of the name of the US state. And we can use these numerical variables in scatter plots to examine relationships. So here's a scatter plot of percent who are obese in each state and the percent who smoke, right? So you can see here that on the x-axis, we have the percent in each state who smoke, and on the y-axis, we have the percent who are obese. By convention, we label the axis at the bottom the x-axis, and the axis on the left, the y-axis. In a similar fashion, we can say the y variable is obesity and the x variable is smokers. That's just by convention. When we have a small set of data, such as 50 states, it's often useful to label the actual data points here. And you can, especially since you can see, you can kind of just check to make sure that these findings make sense. So in this case, you can see that one state off there on the lower left-hand corner has a low percent obese and a low percent who smoke. And then we also have, that's Utah, which makes sense given the religious and demographic makeup of Utah. And then we have various other states. So you can see there's quite a bit of variation. One key point, though, is when we're looking at this graph, there seems to be some kind of pattern. Okay, in particular, we can say that states with a low percentage of smokers, they also tend to have a low percentage of obese people. Not always, but in general, you can kind of see, looking at this blue area, that seems to go together, these two sets of values. You can also see that states with a high percent of smokers, they also tend to have a high percent of obese people. All right? We can say that when these values tend to increase or decrease together, we can say that they have a positive linear relationship. So we can see as the percent who smoke increase in each state, we also know that the percent who are obese, in general, they tend to increase together. And so you kind of see this upward sloping pattern in the data. Again, this suggests a positive linear relationship. You can almost imagine that in a rough way, you can kind of approximate this pattern with a straight line. That's what we mean by linear. Linear is related to the word line and just suggests that there's some kind of straight line relationship. Even if you're not fitting a straight line, there's something in the pattern of data that suggests a straight line relationship. And it's positive because these two variables go together, they increase together, and equivalently they decrease together. So we say that there's a positive linear relationship. Let's look at a different set of variables from our data set. So here we're looking at percent obese and the percent who report eating fruits and vegetables. Right? So on the x-axis, it's percent eating fruits and vegetables. On the y-axis, we have the percent who are obese in each state again. So we can see that the pattern is a little bit different. There's sort of a downward sloping. If we look at the actual scatter plot, you can see, well, states with a low percentage of people who eat fruits and vegetables, they also tend to have a high percentage of obese people. Okay, that's that sort of red quadrant, generally speaking. We can also see that states with a high percentage of people who eat fruits and vegetables, they tend to have a low percentage of obese people. So we can generalize and say, as the percent who eat fruits and vegetables increases, the percent obese goes down. So in general, when the value of one variable increases while the other decreases, we can say that there's a negative linear relationship. Or to put another way, when the values of one variable decreases while the other increases, we can also say that there's a negative linear relationship. It's the same sort of pattern either way. And we can kind of see that there's this downward sloping pattern in the data. And in a similar way, you can imagine fitting a straight line through that set of data. Now let's look at a slightly different scatter plot. This is the percent of obese people and the percent who identify as non-white for each state. So on the x-axis, we have the percent identifying as non-white, and on the y-axis, we have the percent who are obese. So let's look at those states with a low percentage of people who are non-white. Okay, just looking at that value of the x variable of the percentage identifying non-white, we can see that, among those states with a low percentage of people who identify as non-white, there's, you can't really say anything. There's about the percent who are obese. There's sort of an equal mix of states with low, medium, and high percentages of obese people. And then if we look at states with a high percentage of non-white people, we can say that there's roughly an equal mix. The one exception, or the one outlier in this case, is Hawaii, which is in some sense sort of an outlier in terms of this variable because a lot of people in Hawaii identify as Hawaiian. So ignoring Hawaii, since it's an outlier, you can see that roughly there's an equal mix of states with a high, medium, and low percentage of obese people. This kind of pattern in the data, in which as the value of one variable increases and the other variable neither increases nor decreases, we can say that there's no apparent linear relationship. There's, in a way, there's just no sort of pattern in the data. There's kind of a cloud of data. So at this point, just based on scatter plots, we can start coming to conclusions about obesity and relationships between one numerical variable and a set of numerical variables. So based on scatter plots alone, we can say that there's a general positive linear relationship between the percent obese and the percent who smoke cigarettes. So the greater the percentage of people who smoke cigarettes, the greater the percent obese in particular states. We can say that there's a negative linear relationship with the percent obese and the percent who at least 5 servings of fruits and vegetables. So as the percentage of people who report eating at least 5 servings of fruits and vegetables increases, the percent obese decreases. And then finally, we can say that there's no linear relationship with the percent who identifies non-white and the percent obese. So as the percent who identifies non-white increases, there's really no change overall for the percent who are obese. With saying that, we might want to say, well, scatter plots are useful for helping us to visualize two numerical variables. And we can look at sort of a suggestive pattern between the two variables, but is there a way to calculate a summary measure of association rather than guess based on a graph? And it's to that topic we'll turn to in just a moment.